Alright, that was getting too intense. Alright, hi everyone. Can I check that you can hear me? Sound, is it okay? Amazing. Alright, how's everyone feeling? What's the vibes? Last lecture of 1511. Is everyone feeling good? Oof, not many people. Yeah, it is very sad. But you've got so many cool things to look forward to. So much fun. And also so much K17 noise behind me. They are maybe taking out the stairs, so I've chosen a terrible day to do a lecture from here. Okay, let me increase this sound so maybe you are not going. Okay, there we go. We'll try it like this. Okay, have I submitted my assignment too? Well, no, it's due on Friday. Why would I have submitted it early? That would be silly. I'm going to submit it on Friday at 6 p.m. when it's due. Okay, let's, should we pick up where we left off? And let's do a little poll to, who's with me? I've got Sophie, Isabella there as well. So can you do a poll for me, please, to, I guess, you know, what's our vibes? Do we want to see, which questions do we want to see? After the one that we started yesterday, we're going to finish it. We're going to finish it. I'm going to draw it out to start with. Okay, so, and tell me what you were, tell me as well what you are feeling most nervous about. You know what, do you have any questions about the exam at all before we start like into doing questions and revision? Any questions about the exam? Anything you want to know? Anything you wish you knew? Anything you're nervous about? No? ArgC and ArgV practice. Okay, I'm going to have to make that up on the spot, which is okay. We can do that. We will put up on the forum how to sign up for revision classes. Is there a pattern to the style of questions? There is a pattern. If you look, we're going to release at the end of this week, we're going to release 3 past exams, and you will be able to see the patterns. But the pattern is basically linked list, easy, array, easy. So linked list, a question that doesn't require you to insert or delete, but find something and do something based on that finding. Array, similar thing, traverse and find something. Then linked list, insert or delete. Then array, more complex array movements. Then you're going to have debug, 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 which can have anything in it, and debug, debug, debug. Then you're probably going to have strings, and then you're going to have a harder linked list or array, depending. And then just a really hard question that you decide what you want to do. Yeah. And I'll say again that passing all your auto tests does not mean that you've gotten full marks, right? Because you can pass auto tests just by hard coding what we have in there, right? And we want to avoid that from happening. We want you to actually show that you've learned something. So that's why we're going to have hidden auto tests that will test something that was not on the auto tests. It's only for the marking, which lets us see whether or not you are hard coding your questions or not. So we will be able to mark it based on that. Is get enough score when complete? Yeah, because you don't need to pass the exam, right? You need to pass the whole course, so you need to get 50 or above in the whole course, and you need to pass the 2 hurdles. Fully get full marks for one question in a hurdle. No, you need to get half the marks in one of the hurdle questions to pass that hurdle. Results from the prac exam we do this week. Well, you'll be able to see the results basically because we've also released the answers to the prac exam. We will release those, and you can see from, yeah. Yeah, it is not worth hard coding. It's a waste of time because if you pass, all your auto tests and then you fail the one that we do and I mark it manually and I see that you hard coded, you'll just get 0 for that question. It is not worth it. Any other questions? I love questions. No. We shall continue. We shall endure and continue. Let's do that. Let's endure and continue. Hard code is when I know that the output has to be 7. If the input is 3, I will say if the input is 3, then print out 7. I will not do anything else, right? That's what hard coding is that you don't actually have any logic in your code. You just have hard-coded answers to meet the auto test. You're not going to learn recursion. You're going to learn recursion in the next course because there's just not enough time in 1511 to properly do recursion. Not yet, but there might be when we move back to semesters. Then will we be asked technical questions like how much memory a variable holds? No, you will not be asked questions like that. Because that's not really something, it's something that you can check very quickly, right? It's not something that you ever really need to know. So if you get 50% in a 1 dot hurdle and 0 in the 2 dot, you pass the hurdle. That is correct. Yes. So if you get 50% in your 1 dot hurdle and you get nothing in the 2 dot hurdle, you've still passed the hurdle, right? So you have to pass either one or the other. But you have to pass both a linked list and an array hurdle. If you pass the course, you're never coming back. That's correct. You're never coming back to 1511. You're moving on to bigger and better things. Yes, you can use size-off to find the sizes of things. And is that it? That's it. Sad. Okay. Is huddle supposed to be the easiest question? Is the hurdle supposed to be the easiest question? Needs the 1 dot hurdles? I don't know. No, I think the debugs are easier, but the hurdles are there to ensure that you have enough knowledge and understanding to go on to do 1521 as well. You will know what the hurdle questions look like based on the prac exam and the prac exams that we release to you, okay? They're all past exams. They're not, so they give you a really fair indication of what it is. It's definitely not your last month with the C language. You're going to be doing C in 1521 as well and MIPC. How much time should you spend when completing the question until the debug? Okay, so I have seen exams, every exam period, I see exams where people will spend the whole 3 hours on the hurdle questions. I mean, at some point, so you need to pass the hurdle to pass the exam, okay? But it's also possible that you need to take a break from the hurdle and just, move away to something else, then come back to it. So use your time wisely, okay? And basically try and pass a hurdle. When you've passed a hurdle, that's when you can move on. When you pass both an array and a linked list hurdle, that's when you should move on to the debug questions. Otherwise, you can use them for like to get a little bit of a break, but not, like don't fixate on a question and then stay with it for 3 hours and then, panic. So be careful with that. Also, the reading time is 10 minutes, not 15. I did tell you I get confused about that all the time. Reading time is 10 minutes. So you'll have 10 minutes before you like touch the keyboard, before you do anything, to read through the exam and see what the questions are like, okay? And that will kind of ensure that you are, that you are not in a panic trying to read and understand all at the same time. So, yeah. Yeah, and it's like, it is true. Like sometimes maybe the debug question will give you an idea for the hurdle question, right? So make sure to read the exam in those 10 minutes and stay calm, right? You can't control the exam to its full potential kind of thing, right? So just try and stay calm and go in there, draw out what you're doing and then kind of work from there. What if you accidentally type in the reading time? You're going to be called out for it, and we're going to like move your keyboard away. They're going to call me and I'm going to have to come and talk to you. So don't do that. Please. Thank you. Yeah. You will be told not to. You will be told explicitly 10 minutes reading time, and you will be told explicitly at the end of those 10 minutes, reading time's over, you can start, right? And then you will be given a 10-minute warning before the end of the exam, and you will also be told, please submit all your answers. So the invigilator will remind you to submit your answers. So if you wake up on the morning of the exam and you're not well, so you are sick, you do not come in. You go see a doctor, you get a medical certificate, you apply for special consideration, and then you sit the supplementary exam, which will be sometime during O week. Practice questions are quite simple, quite similar to the style of the questions that you will see. They are actually past papers of exams. Is there an O week? Yes, there is. There's an O week every term, but it's not as big as the one in term one. So term one is the biggest O week, and then you get O week every other term, but they're not as big and grand and not as much. But there is, you can still get the free energy drinks on campus. So there you go. Most important thing. At the end of this week, we will release some papers for you to practice with. So, okay, yes, if you show up, you have declared yourself fit to sit the exam. That is fit to sit rule. But, okay, if you start feeling sick during the exam, raise your hand straight away, okay? Raise your hand straight away. We will send you to the doctor. They will give you a sup exam if you are genuinely not well, right? No one expects you to sit through the exam if you're vomiting or if your fever's gone up or if you just feeling awful, right? That's not testing anything. Okay, and you will have access to the course website, you'll have access to the lecture code, you'll have access to the tutorial code and the lab code. So our solutions, not yours. Yes, they will be released at the end of the week, and you will be able to attempt the practice exam questions in our environment, not in the exam environment. Yeah, I mean, like the sup exam is not that fun. It means you don't really get a break at all. You're going to have to study through your break, and it's always like sitting over your head, right? Over your head. Is that how the saying goes? Anyway, so you just come in, sit the exam, and you cannot resit the exam. You cannot retake the exam if you fail. If you fail, you fail. You cannot carry notes to the exam. You do not have DCC help. You do not have DCC sidekick. You do not have auto test help, and you do not have AI, which is why for the last 10 weeks I've been telling you, please don't make AI your crutch. Please learn something. Please try and do like the hurdle types of questions on your own. It's really important that you learn something. It's so, learning is fun. You know, keeping the brain moving is fun. Are there windows in the exam room? There are windows in the exam room. And air. It's your labs. That's where you're sitting the exams. And a student ID. Please make sure you have a valid student identification. Yeah. Okay, great. Should we commence? You do get man pages. No VS Code extensions are enabled. We will do an erase question. Yep, that sounds good. I'll finish this linked list, then we'll go to, and you'll get scrap paper as well. Yeah, let's do it. Onwards and outwards. All right, I'm pleased the attendance has picked up a little bit as well. You'll get scrap paper, and if you run out of that scrap paper, raise your hand and you can get another piece of scrap paper, unlimited scrap paper. And if you have a water bottle, make sure it's a clear water bottle, right? It cannot be a dark water bottle. It cannot have images on it. So just a clear water bottle. Yeah. Okay. So we, what did we do? So I'm using the last, yesterday's lecture notes because nothing's changed. Course feedback still the same, my experience please. And then we went straight to problem 10. And what I'm going to do now, because all of you were just so cooked, and I hope it was not from me, I hope it was from Tom, which I will put all of that up as well sometime this week. But I'm going to draw up what we were doing, and then we're going to decide where were the logic errors. So if you remember, we had a logic error in this code. And so now we're going to try and fix that logic error. So let's draw it up. So let's say we've got, we're going to do it with some nodes, and those nodes are going to be, it'll be helpful to switch my pen on. There we go. Okay, so I'm going to do 2, 3, 4, and then I'll do another one, 5, then we'll do 6, and then we'll do 7, and then this will be the end. And I'll link them all up together. Okay. Okay, so then what have we got? Okay, so I'm going to do some pretend addresses just to make it easier. Okay, and that means that we have this one is going to B, this one's going to C, this one's going to D, this one's going to E, this one's going to F, and then that one's going to null. And over here we have the head of the list, and the head of the list is equal to A, which you cannot see. Okay, so we've drawn it now. And so okay, so what have we got? Someone's very obsessed with traversing a list backwards. We haven't done that, okay? And we don't do it in 1511 because we're going in one direction, right? Okay, so let's go through the code and see what we have and see what we need to do. So if you remember, after every 2 nodes, insert a new node whose value is the sum of the previous 2 nodes. Okay, great. So let's start going through the code as though we are the machine, and let's see what we're missing or what is not happening. So if head is equal to null or head next is equal to null, so we've checked head has a value in it, and head next, so if I go to head next, that's got a value in it as well. So that means I've got so I've got at least 2 items in my list. It's not empty. So I'm not going to go into this if statement. I'm going to move on down. So I've got a struct node current is equal to head. So that means my current is currently here. So current is equal to the head, which is equal to A. That means that this one over here is current next. And this one over here is current next node. Yep. Okay. So what we've got is something that looks like that. So great. So now we've got this. So let's keep going. So we move on. We go into the while loop. Whilst current next is not equal to null. So what that means is I go to my current and I dereference my current. Then I go into the next, and then I go into the next. So that's not equal to null. Great. That means that this is true. So I will go into here and I will have a new variable. And my new variable is going to be sum. And sum is going to be equal to current data. So current data over here, 2, and then plus current next data. So plus this one. So sum is going to be assigned the value 5. Great. I am now have a value for my node. And so now I'm ready to insert that node. So what I'm going to do is I'm going to actually create and allocate some memory for that new node that I want. So on line 27, I'm going to malloc some space for a new node. And what that does is it creates some space for a new node, which is going to have enough for a whole node. So enough to store some data in a next. And it's going to be called new node. And this new node might have some sort of address at G. So that means that that address is now assigned to my new node. Then I go to new node data and I assign it the sum. So I assign it the 5. That now goes into my new node. And my new node next is going to be equal to null. So now I've got this new node. And what I want to do is I want to put this new node in to here, right? And that means that I want my current next to connect to my new node and my new node to connect to my current next node. Okay, so what I've done in here is I've said new node next. So new node next, this bit here, I'm assigning the value of current next. So I'm assigning the value of C. So that's now going to be C. And my current next, so this one here, is going to be assigned the value of the new node, so G. So what I've just done is I've created this link here, and then this link here. Great, and then what I've done is I took the current and I moved the new node onto the next new node next. So that means that my current has now gone over here. So my current is then equal to C. Great. And then I will go back and I'll check again. Is current next equal to null? So if my current is over here, this is my current next, this is my current next. So it's not equal to null. Yeah? Great. So I'm going to go in here and I'm going to go again. Sum is going to be equal to current data plus current next data. So sum is going to be equal to 9. And I'm going to malloc a new node. And that new node is going to be located at some address. And the new node is going to get the sum as the data, and then it's going to get null as the next point of it. Then I'm going to try and connect it. So what I'm going to do is this new node next, so this part here is going to be connected to current next. So if this is current next, this is current next. So that's going to be E, and my current next is going to be to a new node. So this one here is now going to be current next is going to be equal to the new node. So this is current. So this one is now going to go to this node. And this one was to this node. Is that correct? I've got so many arrows now. And I think it's not correct, right? Because it should have inserted it. Where did we insert it? That means we've inserted it after here, no 9. And this one's, oh no, it might be correct. Okay, so, and then we go again, right? So I've got the 9 now, and then we've got 6, 7. Great, so then I'll go current new node next. So my new node next so that means that this is going to be my current now, yeah? The arrows went off screen, they did, and off my head as well. The arrows, I don't know how helpful they are. I overcomplicated the arrows. And yes, you are kind of lost. I feel that very strongly because there's been no chat in the chat. So let's have a look what it does for us before we continue, and then we can see how we can fix it where the mistake occurred, because I think I got lost in current next as well. So there is a more clear way to do it. Let's do it in a second than doing this current next, which frankly has traumatized me as well. Let's have a look. Let's compile it and see what it gives us. Okay, and problem 10.c, spelling, not that it matters there. Okay, so then we have compilation, so let's run it. And 2, 3, 4, 5, 6, 7. So we would expect it to look like 2, 3, 5, 4, 5, 9, but that's not what we're getting. We're getting 2, 5. So we've lost the 3 somewhere in there. And we've lost the 5 here. So we keep losing one node in each case. Yeah? Yeah? So so the last 2 nodes are there, but you're right that there is nothing for them. We're not adding them up, and we've lost every second node, because what we should end up with should look something like this: 2, 3, 5, 4, 5, 9, 6, 7, 13. But that's not, we're missing our 3, then we're missing our 5, then we're missing the 13. Yes, so we've lost the last 2 nodes, and we've also lost a few other things. Yeah. Okay, so should we fix it up a little bit? Should we try and get rid of some of this current next stuff and do it slightly differently? What do you reckon? Should we try and fix it up a little bit? Yeah, let's get rid of a little bit. Let's fix up the code a little bit just to see how we can do it without the current next. Okay. You know what? So someone's saying, I reckon restart. And quite frankly, if in the exam you have got an absolute dog's breakfast happening in your code, sometimes it is better to just comment it all out and then restart, okay? Than trying to fix something that's like so heavily broken that you've now lost all sense of what's right and what's wrong. So it's not a bad thing, right? Okay, so should we do just that? Exactly what I said, and let's do just that. Okay, so I'm gonna just comment this out. Not all of it is wrong. It compiles, it does things. There is a logic error. This kind of code with these kinds of mistakes, that would probably get you a pass on the hurdle, right? So let's restart and let's see what we've got, and then we can talk about what went wrong in this current code. Okay, and yes, some people are picking it in the chat, right? They can see that because we've lost one node, that means we're not doing the right pointing, right? It means that we're pointing from here to 5, and then we're doing the correct point. Current next is pointing right. The new node next is doing the correct point, but not our current node to the new node is not doing the right pointing. So let's have a look what we can do. Okay, so I'm going to keep the struct node current is equal to head because that's always useful to traverse, okay? And of course, even if you don't pass auto tests, you of course get marks for writing code that's kind of close. Absolutely, right? And that's what I mean. This would not have passed any auto test probably, but it is halfway to a solution or even more than halfway to a solution. So you would get the marks that show that, okay? So you absolutely get that. Okay, any code that is submitted that does not pass all auto tests goes into a manual marking pool and is marked manually. All of the hurdles, all of the nines, not the debug questions, but everything else, okay? So everything is manually checked. Okay, so let's do our condition. And I'm going to say, because we can see that here we didn't go to the last node, right? We skipped over it. Because when we got to this node, current, and then current next, and then current next is equal to null, right? So what it did is it finished out of this while loop and it returned the head, which is why it did not sum up the last two nodes, okay? Because of this condition here, it did not sum up the last two nodes, because if you're standing on the current as this one, and then you will skip over and your current next is going to be null, which means that you're going to exit out of the while loop. Okay, and that's why you will miss that last the last join. So often if something is missed at the end, it usually means that this condition inside the while loop is not quite correct. So we're going to do until current is not equal to null, okay, which will get us up to the last point of the list. But we're also going to check that current next, struggle town, current next is not equal to null, which will ensure that we have enough elements there to not dereference the null pointer, which we'll have a look at in a second. Okay, so things are still the same in that I'm going to have an in sum, and that sum is going to take the current data and it's going to add it to the current next data, which is just taking two nodes and then adding them up together. Yeah? Okay, great. Okay, so we've got that. Then this is going to be exactly the same in that we're going to create a new node and get ready to insert the node. Okay, so this is creating a new node, and then we will get to insert the new node. Okay, so we've created it here, and now is the time where we actually need to insert it. Okay, so what do I want to do here? Okay, so let's say I'm standing at this is my current, okay? And I've just added 2 and 3. So I want to take where current next is pointing, that's my tail, yeah? So what I'm going to do is I'm going to basically try and like splice out the list, okay? Well, in my head that makes sense, but what I'm trying to do here is I want to basically have a current node, then I want to have the next node after the current node, then I want to have the new node, yep, and then I want to have the rest of the list. Okay, so this is kind of how I'm thinking about it, right? And that's how I want to splice it out. Okay, so I'm going to insert it after the second, so after the next node, that's where I'm going to insert it, and then I'm ready to go. Okay, great. So I'm going to, and again, there are many ways to solve this, okay? This is what's making sense to me. We will run through the code. So what I'm going to do is I'm going to have my second node. That's my second node up here. That's the next node. And I'm going to do it like that, right? For me, that then gets rid of current next and current next, okay? Because now I just have my second node. Okay, and for me, it's easier to think that way. Okay, so now my new node next. What do we think is going to happen now? So do we think this was correct before? So we've got current next, now it would be second node next. Or what would it be? What do we think? Complete rewrite was unnecessary, but I was trying to demonstrate that sometimes you're better off starting afresh if you get in the exam and you are stuck. Yeah, new node next, second next. Yeah, which is really the same code. We just kind of got rid of the we just got rid of all the next to try and make it less confusing. Okay, and then second node next is going to be equal to the new node. And then I'm going to move it along, which I was doing before as well. So current is equal to new node next. So do we think that this is going to fix our issues? So what we've done is we've made sure that our two nodes are working, right? So our two last ones are adding as well. Should we see if this works? Do we think it's going to be broken? We've done everything quite identical except we got rid of current node. I agree. We got rid of next. No problem. 10, 2, 3, 4, 5. I don't know why I needed to look. That's not a complicated list that I needed to look. Okay, 2, 3, 5, 4, 5, 9, 6, 7, 13. Okay, so we did one thing. We changed the loop condition. The loop condition allowed us to capture the right nodes, right? That's where the logic error was occurring. Okay, now the reason I started rewriting it is because current next was quite confusing, and it can get confusing. So one way to kind of remove that confusion is to store it into another node, right? So then you just have one next as opposed to two next or three next. If two next makes sense for you, please keep going, right? And I think I wanted to show you sometimes in the exam, what I see is a complete dog's breakfast of someone just trying to constantly change, and then they start getting stressed because actually the thing that they had before was working better than what they have now. And so now they've got an issue. So comment it out, start again. That way you also have a history of what you had before that you can go back to, right? Just comment it out and then start again. Yeah? How's that? Does that make sense? I mean, we can do current next, then we can get to the end and do a final sum, but that's not neat coding. This one is taking care of like all of those cases and doing the last one as well. How is that feeling? So don't be worried. Use the long comment to comment out chunks of code and then just go again, right? Start again. You know, it just makes it easier. So you're right. So we now, you're saying we don't need the top condition now because it would just skip over it if current is equal to null or if current next is equal to null. Yeah, so we've got this is now the same as really this. It will skip over it and go down to return head. So we could now also go without all of this, right? Because it's redundant. And then double check that it's all still good. And it's all still great. Yeah? Okay. Feeling good? Can we do a poll? Do we want another insert question? Or do we want to move on to an array question? Insert or array? Array, 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 array. Okay. All right, let me see what I've got for arrays. Let's have a look, and then we can do an array. We can always come back. This is one dot array, one dot array, two dot arrays. Yeah, two dot array. Can I, where's my glass of water? I can't. Okay, how's this question? You're gonna hate me. Okay, so function sum continuous subarray should return the largest contiguous, I do love the word contiguous, it just means continuous, sum of a subarray in a given array. Does that make sense what it's doing? Do you understand the very crappy spec that I've created here? No, so what it means is, it means if I have, I'll show you, hang on, let me open it up. And I'll show you, I'll type it out, 13. You know, to make you feel better though, this is, you get much better specs and examples in the exam, okay? I am speaking English. English is not my first language. Okay, so what it means is, let's say you have an array and the numbers are over here, 8, 3, 5, 4, blah, 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 blah. So return the largest continuous sum of a subarray. So the largest continuous sum in this case will be, if I do 8 plus 3 plus 5 plus 4, that will be the largest sum in this array of continuous numbers. I promise you in the exam, I make sure that the English is like very easy to understand, but also there's examples in the exam, and each question has examples as well. And we also test the exam so to make sure that someone other than me and my insanity can understand it, you know, or one of the admins and stuff. Yeah, and each exam question has many examples to go with it. This could be like a second 2-dot hurdle question, right? Just much better described in a hurdle question. Yeah, so like a two-dot hurdle. And so even in your 2-dot hurdle, you'll get this message as well. This is a simple main function which could be used to test your subarray function. It will not be marked, only your sum will be marked. But what this is doing is it's calling your function that you're doing, and then it's printing out, so that means that you don't have to worry about printing in the testing. And it's giving you can change this array when you're testing your own thing, right? Because then you can see if it's working. So in this case, this one should return the sum 8 plus 3, 11 plus 5, 16 plus 4 is 20. So this should return 20, because then if you do 20 minus 8, you'll get 12. So now the sum is smaller. Basically, it's saying what is the largest sum of numbers next to each other that you can get in this array. Yeah, this would be a 2-dot. This would be a harder 2-dot as well. Okay. How do you feel before you start this question? How would you approach it? What do you think? So the question is, we're going to write this function, yeah? We're going to write a function that is calculating the largest sum of numbers that are next to each other in the array. That's basically it. Sorry, I don't know why my voice went up as though I'm asking a question. Often people find the array to be the harder hurdle to pass. Not 2 numbers next to each other. It could be 3 or 4 or 5 numbers next to each other. It could be a whole array next to each other. Yeah, so you will need to compare first plus second, then first plus second plus third, first plus second plus third plus fourth until you reach the last number or until there is a lesser sum. I think the hardest part of this one is how to approach the actual solution. Yeah. You will not need to use size of because you're given the size of the array here, or I mean, let's do it. Okay. Should we do this question? Let's just do it. So we haven't taught you to do size of array divided by size of array 0. But I mean, it's something, yeah. You just assume in our question that the size of the array is size, and that size is populated. Okay. So let's do it. I'm going to do it, I'm going to do it in a few ways. Okay, I'm going to start with, okay, so number one, I'm going to start with the first element, and I'm going to decide that the first index holds. We can do an example, okay? Don't worry. Yes, we can do an example where it's not just the first number added in. That the first index spelling holds the initial max, okay? Did you see that? I just indexed it at 0, not at 1. Ah! Okay, great. And I'm also going to, so I've got my largest kind of number so far. I'm also going to keep track of the largest sum, okay? So my current max is going to be, and I'm also going to set it, oh my God, I'm struggling with arrays as well. No, I'm struggling with just writing. I'm struggling with, yeah. Okay, great. I've got two variables. This is probably, no, I don't think I've gotten many marks yet in this question. Okay, great. So I've got an array, okay? If I've got a one-dimensional array, I'm going to have one way to traverse it. If I'm going to have a two-dimensional array, I'm going to have, two loops inside each other to traverse the two-dimensional array. Okay, so always think of the building blocks that you have with which to solve the question. Okay, so first thing I'm going to do is I'm going to int I. I'm going to start it at 1 because I've set everything here to 0. So I assume I've already got my 0th index of the array. So now I'm going to start at 1 because I want the next thing to be added to my array. Yeah. Oh God, choking. Okay, so int I is equal to 1. No one's fighting me on that, so I'm going to go with that. I is going to be less than size. Great. And then I'm going to I++. So I've got a loop. So now is the time for me to decide some things, some important things. So I need to now decide whether to start a new subarray or add the current index to an existing sum. So does that make sense what I'm saying here? So I'm going to decide whether this number is going to result in me being thrown off that, like it's going to result in a smaller sum now, or whether I'm going to keep adding it to the sum. Okay, so now this question is not going to be very efficiently solved in terms of efficiency itself, because it's just going to keep, it's going to do that loop for each one and try and find it for each one. We'll draw it out. We'll see what it's doing, but we don't care about efficiency yet, so why not? Okay, so I'm going to check my if condition here is going to be, I'm going to check whether my current item that I'm standing on, array at index I, okay, is greater than, okay, my current max. So this sum that I'm keeping track of plus my array at index I. Yeah? If, well, 0 is larger than the largest negative number, mathematically. Okay, so if my if my element at index I in that array is greater than the current max plus my array at index I, then I'm going to change my current max. And I'm going to make it into array I. Or I'm going to do something else and I'm going to add it to my current max. So see this is what happens when you do too many linked lists. Current just becomes, I never stop typing it. So then current max is equal to plus array at index I. Okay, and we will go through it, don't worry. Okay, great. Oh my God, who's given me a style warning? You are correct. Yeah, it's because I started writing this comment and then I lost my way. How many marks would I lose? Oh, skull question at speed run. God. I'd have to dig out a past one. I haven't got one with me. They take a lot. I can't just make those up on the spot. Those take a few hours to write. Yeah. Sorry. We should record a video of solving it on a speed run one time. That would be fun. Okay, great. And if I now found my maximum, then I want to update my maximum number, because right now my maximum so far is just the very first thing in the array. So I'm going to update it. So if my current max is greater than the max so far, then my max so far is going to be equal to the current max. Okay, great. And then I'm going to return the max so far. All right, what do we think? Should we quickly draw it out to see what it's doing before we run it? Who wants to draw it up? Anyone? Draw. Okay. So the hardest part of this question is the question itself, right? It's not the syntax, but it's how we're solving it. So let's draw it out so that you can. How likely are you to recommend whiteboard to a colleague? Not very right now. Okay. So let's say we've got this array over here. Yeah. So I'm going to do 8, 3, 5, 4, minus 8, minus 3, minus 5, minus 4. Great, that's our array. And we're now going to go and look at what this code is doing and how we actually went about solving it. Now, also, I want you to keep in mind that this is probably the first time that you've seen this type of problem that needs you to go like into a subarray or needs you to find a portion of the array. So you're like, I don't get this. This is crazy, right? However, okay, finding parts of an array or finding like the smallest sum of a part of it, it's actually quite a common problem that you have that you are solving. And once you've seen it a few times, you then know how to approach that problem. So this is why we always say, do a lot of practice, because the more questions you see, the better you get at knowing how to actually approach it to solve it. Okay, great. Let's do it. So we've got a few things here. Let's do it. And it's highly likely that the exam question is not going to be quite this hard. I'm trying to remember it's actually, no, it's not that hard. I remember what I wrote now. Okay, great. So I've got two variables. My first variable, max so far, and this variable gets assigned the first part of the array, so the first index, which is 8. Then I have my current max variable, and my current max variable also gets assigned the thing at the 0th index of the array. Okay, fantastic. Now I'm going to start. So I go into my for loop. In my for loop, I've now got a variable I, and that I is set to 1 because I've already taken care of the 0th index. It's already sitting inside my current max, which is the thing that I'm going to keep to add up into the sum altogether. So I've already got the first element in there, which is why I now start at the second element of the array. Okay, great. So now I'm going to check whether or not this sum, okay, so my number here is greater than the current max plus array I. So my condition here is I'm checking if array at index I, so if array at index 1, so is 3 greater than my current max, so my current max is 8 plus the array at index I, so 8 plus 3, 11. Is 3 greater than 11? No, it's not, okay? Which means that I'm going to add it onto my subarray. So this is not true, so I'm going to go to the else, and what I'm going to do is I'm going to add this current max plus array I, and I'm going to say that's now the maximum. So now I've taken these two elements together. And I'm going to update my maximum. So if my current maximum is greater than the max so far, so my current max is 11, my max so far is 8, it is greater, I'm going to reassign max so far to be 11. Yeah. Great. And I go back and I increase I by 1. So I goes to 2. So now we're standing over here. So I'm going to check again. Is whatever's sitting at array at index I, so it is 5, greater than my current max plus array I. So my current max is 11 plus array I is 5. So is 5 greater than 16? No, it's not. So that means I'm going to follow the else loop and I'm going to add it to my current max, so that my current max is now going to be 16. Then I'm going to check, is the current max greater than max so far? It is. So I'm going to reassign the max so far to be 16 as well. Okay, great. Then I'm going to go back, increase I by 1, and we're going to go to number 3. Great. We've now encompassed this, we've moved on to here. I'm just going to get to the first case where it doesn't work, okay? So you can see what happens. So I've gone to the the third element of the array, and I'm going to check again. Is this element greater than current max plus that thing? So is it greater than 20? No, it's not. So I'm going to go back to here and I'm going to add it up. So this is going to become my 20. And then I'm going to update my max in the next if statement over here. Great. I'm going to increase the I by 1. It's going to go to 4. And that means now my sum is now this. And I'm going to go to this negative 8 here. And I'm going to check, is minus 8 greater than current max? So 20 plus negative 8, which is 12. It is 12, right? I'm struggling. Okay, great. It is not greater, so I'm going to go back to here. And I'm going to add it on. Is it greater? No, it's not greater. So I'm going to move to my current max and I'm going to add it to the array I. So -8. So that's now going to be 12. And I'm going to check, is my current max greater than max so far? No, it's not. So I'm not going to do anything there. And I'm going to increase I by 1. And then I'm going to check for the next. So now I've done these sum, okay? And I'm going to go in here and I'm going to check again. So is -3 greater than 12 plus -3, 9? Oh my lordy lord. It is not, so I'm going to go back to here and add it on. So that's now going to become 9. So I'm really starting to decrease here, yeah? And I'm going to check, is 9 greater than 20? No, it's not, so I'm going to keep going. I'm going to go up by 1 again, so now I'm over here. And I'm going to check again, is -5 greater than, what's 9 plus -5? So now it's 4. No, it's not. It's not greater, so I'm going to go here and I'm going to add it up. And that's going to give me a 4. This is not true, so I'm not going to change anything. And I'm going to go back, increase by 1. And finally, I'm going to go to the last element of the array and I'm going to check again, is the index greater than, it's going to be 0. It is not greater than, so I'm going to go to else and I'm going to add it up. So that's going to be 0. I'm not going to update anything here. And when I go here and increase my I by 1, I'm going to stop and I'm going to pop out of the loop and I'm going to give them 20. Okay, that was a nightmare. Should we try running it? And I've just missed all that chat because I was trying to run through and it probably still doesn't make sense. Does it make sense or not really? Okay. No. So it did give 20 back. So we need to restructure the array. So what I'm going to do is I'll test a few more things. We're going to have a 2-minute break. The exam exercise is not going to be as bad as this one, but I always love to show this one because, I have one for a string array as well like this, actually, which is more of a nightmare, I think, because it's like a really common it's a common program. Where is it? No, I don't even have it in here. But I like to do one with a string array as well, where you look for a continuous same word as well. Let's change the array a little bit. So let's see if it returns the right thing now. What should it return now? Should return 8, 12. Yep. Okay. What if we have, is this going to be a nightmare for me to calculate? What if we have negatives? Oh God, it will be a -3 plus -5, right? -8. Zero? How do we get 0? We should not get 0 because it doesn't even go into the loops. Yeah. Can I swap -4 for 20? So what I propose is we take a 5-minute break, then we come back and I'll talk you through the actual problem solving, why we've done it and why we're doing what we're doing, okay? So it's not an easy problem and it's the problem itself that's the problem, okay? the array can have a single number, and then that number would be the maximum. Okay, so 5-minute break. Then when we come back, we will go through the problem solving bit. Okay, so we will be back. Let's do 3 plus 13. Amazing. I'll leave the code up as well so you can see it. All right, we're back. Yay! In case you missed this cooking. Okay, so we're talking about this problem. We're deciding why is this the so again, there are many different ways to solve this problem, right? And what we're doing here is in the way that we're solving it. So, for example, we're keeping track of the maximum sum that we have, but we're also keeping a track of the current maximum, the additions that we're doing as we're going. And what we're doing here is we are using this line to decide whether our sum that we're doing is still benefiting us. So is it still positive, or is it negative and now it's not worth to go on and we start again. So this is the line that decides whether or not we keep adding. Maybe there's going to be something positive happening, or we start fresh. Okay. So the example that was there below didn't have like the bit where you would trigger this condition where you just start afresh. So this condition is really like saying, okay, if that number is not worth adding to the array, then we're going to make that the new start of the next subarray, and we're going to just drop the other thing and try again to see if there is a bigger sum. So that would be, let's say our current max is minus 10, and so like let's see where it would trigger. So let's say, for example, the current max is going to be equal to negative 10, and our array at index I is equal to 5, right? So in this case, I'll get minus 10 plus 5. That's going to be equal to negative 5, yeah? So that means that the sum of these two numbers is still less than what the number at the array was. So in this case, I'm just going to start afresh because clearly the sum is not going to improve because my number in the array is greater than the sum. So this is taking care of all of those negative numbers, right? So I'm just deciding, is it better to add the number in, or is it better to just now start my new subarray from that point? Yeah? Yeah. So is it better to add it to the previous numbers, or is it better to just start again? So in this case, if my max is minus 10 and my current is 5 and I add them together, I get negative 5. And the negative 5 is less than what the number in the array was. So I'm assuming that actually I now need to just start again because this 5 is going to be bigger than the minus 5, right? So the sum of what came previously. Yeah? So yeah, so it's checking, it is checking. You can leave the message. It is a particular algorithm, yes, and it is there is a timing in which it can be done, but it is checking whether current max is negative, basically. Yeah. Because you can have a negative number, right? And that, like, so you can have a negative, like -1, right? That's not going to, when you add it, it's going to still be bigger. Like, you wouldn't want to start with that. So it's like, yeah. Yeah, you can do brute force, but where's the fun in that? Should we try another array to release the pressure of this array? Solving problems non-elegantly, brute force. What about this one? Yeah, and I'm not teaching you dynamic programming. Don't worry. Everything is, don't, anyway, it's not such a hard problem that you can't solve it. Yeah, did not use, but it's not quite right. Yeah. Don't worry, right? It's not, you need to see things, even though it's, your beginning course. You need to see the kinds of things that you're going to do and the kinds of problems you're going to get. And you're going to get problems that you will learn algorithms to solve, right? Anyway, okay, let's try this one. Read integers into an array from the terminal until a number is entered, which when multiplied by at least one other number previously entered results in 56. I don't know if I like that one. What about this one? This one was close to your checkoff. No, this one was close to your the exam, the lab exam, wasn't it? Kind of. Not quite. Let's do this one. Array of integers, exactly size elements, and a target number. Your function closest to target should return the sum of any two numbers in the array that is closest to the target number. How about that? What do we reckon? Brute forcing a combination lock would just be me getting a hammer and hitting that lock. So it depends. Okay, let's try this one. So question 11-ish. Okay, this is going to be an easier question. Don't overthink the last question, if that makes sense. Don't overthink it. Don't overthink anything, okay? Just take it easy. There are things that you know. Do those steps that you know. All right. Return the number of two elements of the array that are closest to the target within the array. So sample main function could be used to test your sum min function. It will not, that was not what that should be. I clearly copied it from somewhere else. That should be closest to target. Just so that doesn't confuse you. So this is basically just giving you the subarray, sorry, not the subarray, just the array and also the target number. And then we want to find any two numbers in this array that might have a sum that is closer to the target. Great, let's do it. Okay, so the first thing I'm going to do is I'm going to have a closer sum. We really should have done this first before doing the two dot, but anyway. Okay, so I'm going to have a closer sum variable where I'm going to keep track of the sum of the numbers, and then I'm going to work with them to try and work out what's going on. And at first I'm going to set them to the sum of just the first two things in the array. And that's what's going to give me, and then I'm going to modify it each time based on what's going on and what two numbers I add up. Okay, so what do we think we need to do next? How are we going to run through and check everything that's going on? So we want to check each unique pair in the array that's going to go from 0 to whatever size it is. You know what? I have it as a 1 dot, but it's not, this could be like a 1.5 dot. What do we reckon we need to do? So we've got to traverse the array, don't we? At some stage. And I want to be able to kind of keep track of what's going on. So what I'm doing is something like this. So let's say I have, let me draw it for you. So let's say I've got this array and it's 1, 3, minus 2, 5, minus 1. So I want to hold on to this one. And then what I want to be doing is I want to go, okay, 1 plus 3, 1 plus minus 2, 1 plus 5, 1 plus minus 1, and decide whether or not that gives me a target that's kind of greater 2, right? So I want to hold on to, then I'm going to move on to the second element. Yeah. And when I move on to the second element, then I'm going to go, okay, that second element plus this one, plus this one, plus this one. Is it bigger? Oh, God, you can't see my arrows. Is it bigger? Is it bigger? Is it bigger? Right? So I'm going to be each time holding on to one and then using another loop to pull out the numbers from the second one. Yeah? Does that make sense? Because that allows me to check unique pairs. So let's try it out what it would look like. So 4, I'll take the first, so I is equal to 0, I is less than size, I plus plus. And that's the first loop. That's the loop that lets me hold on to, like, say, the 1 or the 3 or the minus 2 that will allow me to move forward. Yep. Then I want a second loop that's going to pick out the next numbers and add them in as I go. So I'm going to have a second loop that's going to do that for me. And J is going to start from I plus 1. Because if I'm standing at the 0th index, then I want to take the first one. If I'm standing at the first index, then I'm going to take the second one, and so on and so forth. Okay, so I'm going to start at J, I plus 1. I'm going to go to J is less than size, and I'm going to increase it by 1 each time. Okay, then you're right. I need something that's going to keep hold of the difference between, yeah, so I'm basically adding two numbers in the array uniquely, kind of thing, to calculate what's going on. So let's do, you're right, I need the difference to calculate the whether it's close to 12 or not. So I've got current sum. No, that's not what I called it. I'm obsessed with current now, and I can't spell either. It's as close as sum. Let's have a sum. Let's have a current sum here, and that current sum is going to be tracking. So it's going to go I plus array J. Let me see, I think I might have a few extra things in here. We'll fix it in a second. Okay, so I've got, and I want my current distance, and my current distance is going to be the current sum minus the target number that I was sent. So minus this target number. And we want this distance to be the smallest possible distance. Okay, great. What should I consider here as well? What if, so if the target is 12 and my current sum is 3, what's going to happen? Yeah, negative numbers. So can I take care of the negative numbers? How can I take care of the negative numbers easily? If you're sitting in the exam and you're like, well, you could just multiply by -1, or you could check it's negative, multiply by -1, or I can absolute value it, which is much faster. Either way is correct, right? So don't, yeah. Okay, so I've got my current distance. What else should I do? Yeah, so each question in the exam is going to tell you explicitly if you cannot use a standard library. And most often that occurs in question 9 when we tell you explicitly you cannot use string.h. You can flip the target and the current sum, but then you need to check whether or not one is bigger than the other when you do your subtraction. So it's just faster to absolute value it sometimes. Okay, so what have we got now? Let's see what we have. If we were to have this list, let's see what the code is doing right now, and we see what else we need in this code. How does that sound? So we've got closest sum, we've got a variable closest sum, and that closest sum is holding the addition of 1 and 3, so closest sum is 4. Then I've got I is equal to 0, and j is equal to 1 because it's 0 plus 1 over here. And it's still all, both is less than size, which is 5, so I'll go in here. I also have the current sum, and the current sum is going to be 0, index 0 plus index 1, so current sum is 4. And then I also have my current distance. So my current distance that I keep track of, and the current distance is going to be current sum, so 4 minus target, which is 12, and the absolute value of that is 8. Okay, what should I be checking now? What should I check? What else do I need to do to see whether or not the next pair is going to be, should I do anything? Because the next thing that we're going to do is, this is going to change to 1. This is going to, no, it's not. No, take it back. I'll take it back. This is going to change to 2, and it's going to go 1 plus negative 2. That's going to be, so I'm going to need to compare the current sum, right? What happens if I add the same number? I probably, yeah, so I don't want that to happen. I don't want I to equal to j. That's a very good point. I want to avoid that situation. Hopefully I'm doing that here when I always have j starting from I plus 1, so it's always 1 ahead of I. So yeah, you're right. I definitely don't want them. I don't want to pick the same element twice. Yeah, so I want to now also check whether or not which distance is smaller, right? Which will allow me to say, okay, if that distance is smaller, then we're good, swap them around. So that means if my current distance is smaller than what? I need something else that's calculating. So here I've chosen the closest sum, okay? So I'm going to update the closest sum and the closest sum is just the first 2, and then I'm going to keep checking it, right? So closest sum is going to be equal to, also I'm going to absolute value that, and see how close it is to the target number. Why can I not spell? I'm so opposed to the T. I don't know why. So I'm going to check whether the current distance is less than the closest sum. And if it is, what I'm going to do is I'm going to change it up. Okay, because I'm going to return the current sum. So this is returning, and it's returning. Okay. Oh, why am I reinitializing it? I don't know. Fun. I should not be reinitializing it. I definitely don't need to do that. Should I be doing that? Is this line potentially? I don't think I should be doing that. What do we think? Should we try it out? Has everyone lost me? It's how I check if everyone's sleeping. It is weird, isn't it? I agree. I forgot to declare anything here, and I forgot to do the same here. No one picked that up. I think it's weird too. I think it's going to cause some issues. Let's have a look what issues it causes us. The closest sum to 12 is 8. Is that true? Yes, it is. It is, isn't it? Yeah. Okay, that oddly worked. Let's try a different thing. Well, that's going to be the same, isn't it? Let's try that. What's going to be the closest sum now? It's going to be 4, isn't it? It's not 4. 5 plus negative 1. That's 4, isn't it? Because it's a sum of two numbers. That's why not just 5. And I don't have a 0. So that's wrong. I think that's wrong. Can someone just give me something? That's wrong, isn't it? It should be 4, because 5 plus negative 1 is 4. So it should really return 4, because 4 is closer than 2. So there is an issue, and the issue is right over here. Yeah. Okay, not going insane. Good. The issue is in this line 19, because I'm just swapping it out without checking anything about it, right? I'm just changing it, even though my closest sum should be the current sum, I'm just changing it to closest sum minus target each time. So what I really want to be doing is this should be the closest distance, and the closest distance should be the closest sum minus the target, and then I check which one is the difference. And then if my current distance is less than my closest distance, then my closest sum is equal to current sum. Okay, that makes sense. Does that make sense to others, or did I just lose everyone whilst I was making it okay in my own brain? Yes. Make sense? Doesn't make sense? Okay, should we draw it quickly, just for a few things? Poll time. Let's do a little poll whilst I quickly draw it out. Poll time. Does it make sense? Does it not make sense? And I will draw it out quickly to show you what the heck is happening. Okay, so the numbers are -10, -3, -2, 5, -1. Okay, great. And now let's run through the code. Okay. And look, like this question was solved in like barely any lines, but it's just the figuring out what the heck to do in there. Okay, first thing I do is I'm going to keep track of the closest sum. That will tell me what's closest to the number 12, to the target number. And the closest sum, I'm just going to make it the sum of the first two elements. So my closest sum is going to be equal to the sum of the first two elements on line 10, which is going to be -13. Then I'm going to go in here and I'm going to grab onto whatever is sitting at the 0th index over here. And then I'm going to take the next number and I'm going to hold on to the next number. And so now I'm going to use those as the unique pair, okay? And that unique pair is now going to be compared. So what I'm going to do is I'm going to have a current sum. So this closest sum is a thing that I'll keep updating as I'm looking for the sum that is closest to the target number. So I'm going to be updating that closest sum. So now I'm figuring out whether this unique pair is going to give me a closer sum than what I already have, or whether that closest sum is the closest I'm going to get. So my current sum, I'm going to add up those first two elements, so I and j. So I is 0. and that means that j is 1 over here. So I'm going to add 0 and 1, and I'm going to get minus 13 as well. I'm going to go over here and now figure out the distances. So my distances is going to be the current distance, which is going to be minus 13 minus the target. So minus 13 minus 12 is minus 25, so it's going to be 25 away because it's the absolute value. And then I'm going to figure out whether my closest sum is closer than the current sum that I have. Okay, so I'm going to figure out whether that is closer than what I currently have. So I'm going to take that sum that I initially set, which is minus 13, and I'm going to subtract it again, and it's 25. Then I'm going to check, is the current distance, so is the 25 less than 25? No, it's not, they're equal. So I'm going to go again, right? And I'm going to increase j by 1. And I'm going to go on to compare with the next pair. So now I've moved over here. And so I've got my next pair now. So it's the minus 10 and the minus 2. I'll add them up to start my calculations. So when I add minus 10 and minus 2, I'll get minus 12. And then I'm going to calculate the distance that that minus 12 has from the target number. So the distance is going to be 24 because minus 12 is 24. And then I'm going to calculate whether that distance, I need the distance that I currently have for my closest number to calculate whether or not they are the same or whether they are less or more, so I can change it if I need to. So I'm going to do my closest sum, which is minus 13, minus the target number, so it's still going to give me 25. Then I'm going to check here, is the current distance, so is 24 less than the closest distance 25? Yes, it is, which means that my closest sum is now going to become the current sum, which is minus 12. Yeah, because now I've just found a better option for my sum. So now I'll move on to the next number. So my j will increase by 1 again. It will go to 3, which means I'll move on to my next unique pair. And so my next unique pair is now going to be, same thing, I'm going to compare. So I'm going to add them up, minus 10 plus 5, which is going to give me minus 5 over here. And then I'm going to subtract that minus 5 from the target. So minus 5 minus 12 is going to, minus 5 minus 7, so it's going to give me 17. And then my closest distance is still going to be the closest sum, and the closest sum is minus 12 now, minus the target. So my closest distance is updating to 24, and I'm going to compare the 17 to the 24. But my current distance at 17 is less than the closest distance that I have now, so I'm going to reassign the closest distance to now be 17 instead. Yeah? Sorry, and the closest sum is the one that's getting reassigned. Oh my God, sorry. Don't cross that out. So this closest sum is now being reassigned to a 17. No, it's not. It's being assigned to a 5. Yeah. Minus 5. I called them really similar things, which is why it's now difficult to understand. Okay, should I keep going, or how's everyone feeling? Keep going, or does it make sense now what is happening in this question? Yeah, let's go one more. Great. So I've gone through. Now I'm going to move on. So I've done minus 10 with minus 3, with minus 2, with 5, and with minus 1. So I've compared all of those unique pairs. So now my j is going to move up by 1. So I'm now over here comparing this as a unique pair now. Okay. So again, I'll go through and I'll add them up. So minus 10 plus minus 1 and minus, so that's going to give me the current sum. And the current sum is going to be minus 11. And then I'm going to, let me move this like this a little bit. Great. Then I'm going to move and calculate the distance that that sum has from the target number. So minus 11 minus 12 is minus 23. So that means my current distance is going to be minus 23, except absolute value. So it's just going to be 23 away from the target number. And then I'm going to calculate what the distance is of my closest sum to that target number to see whether or not I now have a closer distance or a further distance. So I would, so my closest sum is minus 5, and I subtract that from the 12, and that gives me 17. So I'm now 17 away. So my closest distance becomes 17. And then I compare, is the current distance at 23 less than what I have right now at 17? No, it's not. Okay, so I'm not going to reassign it because right now I've got the best situation here. Great. So now J is on size, which means I flip out and I increase my I by 1. And what that means is I will now go to my second element. So I've finished with this one. And so now I'm going to move forwards, which means I'm going to now compare it with this one, and then with this one, and then with this one, okay? So first I'm going to compare it with this one. So I'll do exactly the same thing now. So I'll take the minus 3, I'll add it to the minus 2, and I'll see whether or not what they give me. So minus 3 plus minus 2 is minus 5. So it means my current sum is minus 5. And then I will calculate the distance from the target number. So minus 5 minus 12, that's going to give me 17 is the distance. And then I'm going to calculate based on my current situation. So my closest sum is minus 5 and minus 12, it's still going to give me 17, which means that that's not bigger at all. So I can keep going. So that means my J has reset to 2 in this case. So then my J goes to 3, which means I'm finished with this one. Now I go to this number and then I compare them along and so on and so forth, right? So it's really draw it out, okay? It makes it so much obvious with what's going on. Also, don't do what I just did. Don't name them all in this with C's. That made it, the alliteration in that was quite hard to grasp. Okay, how are we feeling? Does it make sense? Ish. Do we have time to try one more question? We can try. We will not have time to finish a string. That's one more. That's I will just warn you now. Okay, but we can try a string. Do you want to try a string? Isogram. This one's probably not too bad. 3 dot in 10 minutes. I can speed run it through. I reckon I can do this one in 3 minutes. I mean, maybe more than 3 minutes, but maybe you won't understand what I'm doing, but that's okay, right? No, it's not okay. Okay, let's do it. Okay, has anyone heard of the term isogram? It's basically a word in which no letter of the alphabet occurs more than once. So we're going to write some C code, and honestly, this is like an easier 3 dot here. This usually 3 dots can be harder than this, right? But you will get marks for a whole bunch of things. So for example, this question says write a C program that reads in words until Control D is pressed and checks whether the word is an isogram. Great. There is at least 1 mark in reading in words until Control D is pressed. And that is something that you can probably do, okay? Okay, great. So I'm going to read in some words. Yeah, it's not a bad question. I'm going to read in some words. So that means I need an array to keep my words in. Okay, so I'm going to declare an array and I'm not going to initialize it because I'm going to use it to read in. Okay, We only have a main function, but just wait, I'm going to maybe write a function, right? Why not? I think it makes sense to solve this with a little function. Okay, and you can, in these questions, you can have as many functions as you want, okay? You don't have to do it all in main, or you can do it all in main, and we don't care about style, right? Yeah, strings are an array of characters, and they're special because they end in a null terminator. That is what lets us know that it's a string. Okay, so then we're going to use what function to read in some words or some strings? What is the function? I shouldn't even ask. We don't have enough time for me to ask questions. Yeah, but I'm still reading them from the command line. So what do I do? So you're right. We're going to check that it's not, we're going to check something is not null in here. I agree. But what's the function that we need to read in some strings? I know it's been a while. Anyone? 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 Bueller? 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 No one? No, not scanf. Scanf is just for characters. Yes, fgets. Fgets is the one for strings, okay? So we're going to read it into the array that we have said, which is the array name is word. Then we're going to say the maximum size of it. So max is the maximum size of that array. So remember, I think I did it in a lecture. The reason we don't use a scanf for a string is because there's no protection for the sizing of things, right? So whereas fgets, it protects us with this max, so it allows us to it allows us to not overfill the array, which leads to problems. Okay. Sorry that it's not coming through. The chat was completely silent. I was like, oh my goodness, we need to know fgets. And we're reading it from standard input. Okay, so stdin, that's the standard input. So that's telling us where to read that from. And basically it's reading it from terminal. Okay, so now what is going to be... Okay, when you read in using fgets, what else does that fgets read in? I've got 8 minutes. The pressure is so on. It's going to end up to be a speed run at the end of it. But what is there when you use fgets that is annoying? That's not going to be... Yeah, so it's a new line, right? So it's going to read in the new line, and then I'm not going to get an isogram because, well, I mean, I could just do it with that, but I'm checking for characters. So I'm going to get rid of the new line, okay? And the way I'm going to do it is... Okay, great. The way I'm going to do it is I'm going to take that array and then I'm going to do something funky. I'm going to take the length of the word that I've just read in and I'm going to subtract 1 from it, and then I'm going to make that a null terminator. We're now in speedrun territory. Apologies. It's a party now. Okay, and then I'm going to do a function here. So if something is an isogram, so I'm going to flag it and I'm going to give it whatever that word is that I'm working with. Then I'm going to, whatever, printf. I'm speed running, but I can't spell out print. This is an isogram. Great. And then else I'm going to printf. This is not an isogram. What an amazing... Oh, don't want that full stop to be. How random. Okay, now I'm going to write this function. So the way I write code and the way you will find yourselves writing code will be, I just write how I would solve it. And then I write the functions to support that, right? So this is how I'm going to solve it. This is the basic solution, basic steps that I'm going to do. Great. So now I'm going to write this function that's actually going to be doing the magic. So I'm deciding if something is an isogram. That means it's either is an isogram or it's not an isogram, which means that I'm going to have an int returned, either 1 or a 0, to tell me is it an isogram or not. And I'm going to call the function isIsogram, and that function is going to receive a word array as its input. Okay, great. Time, 5 minutes. Okay, speed running. Okay, I'm about to stop explaining everything I do because I'm just going to write and code, and there's not that much to code, but here we go. Okay, we ready? Timer on? No. Okay, I'm going to have an array of 26 elements, and this might be a weird way to do it, but yep, integer array 26, and I'm going to keep hold of it whether something has occurred there more than once, right? Because there's 26 letters of the alphabet. So what I'm doing is I'm tracking which letter has occurred in my situation, and then I will check whether anything is more than one in that array. Yeah? Okay, great. I'm going to have an int I. I'm going to set it to 0 so that I can go through the array that I've got over here. And then what I'm going to do is I'm going to have a loop that's going to go through the array. So I'm going to have a word at index I not equal to a null terminator, which will allow me to go through the whole string and pass through the array, traverse the array. And then I'm going to do some magic. Okay, so nothing has told me in the question whether or not it's a capital letter or not. I saw someone has mentioned it. So you know what? I'm going to now use to lower. I told you I've got to speed run it. I don't have time to write my own functions. This is not the case in the exam. If this is a string, if this is a string function, then what you're going to get is it's going to say that you're not allowed to use it, and it's in C type. Okay, so I've used another function, which means that I've got I'm going to take all the capital letters and move them to lower letters. Okay, so I'm ready to go. So I've got my first character, and whatever is the letter sitting inside the first index of the array, hypothetically, because I've started I from 0. Okay, and if that thing that I've just read through is an alphanumeric character, oh my God. Okay, so that means if it's between A and Z, right? I'm using another function that is inside C type, I think. This is how you speed run. You use someone else's functions. So if it's an alphanumeric character, then what I'm going to do is I'm going to check whether that letter has been repeated. Yeah? So I'm going to check whether or not that letter has occurred before. So my count array at the position of that letter, so the character minus an A, which gives me the position of that letter. So if it's greater than 0, that letter has been repeated. I'll check it in a second. Could have a logic error. Okay, I'll return 0 in that case. Otherwise, I'm going to increase that place in the array. So C minus A. So wherever that situation has occurred, I'm going to increase that by 1. Okay? Okay, so that means I've counted inside my array if something has occurred. Then I'm going to increase my index, and then I'm going to not indent correctly. I need to return something. Where am I? Where's my while loop? Okay, that's my if, this is my while loop, and this is why there was a problem here. Here's my return. and then I'm going to return 1. Okay. How should we try it? Was that fun? That was a speed run. 3:59. Add on time too. Problem 14.c. Yes, please compile. And it did. Problem 14. Let's run it. Okay, first word. Dog. Is it an isogram? Yes, it is. What's another one? Banana. Banana. Not an isogram. Things occur more than once. Next word. Fun is an isogram. Cooked is not an isogram. Yay. Not an isogram. What else? Can we break? Oh, God. Parallelogram. Not an isogram. Nice word. Nice testing of my ability to spell. Oh, thank you, Bella. That is beautiful. Subdermatoglyphic. Oh my God. I didn't even spell it correctly, but it's still an isogram. Square. Code. You can, Henry, what? Move on. Survivor. My God, you really fixated on Henrys and survivors. I can list you characters. Okay. And someone's like, okay, let's do like uppercase and lowercase. I'll do even not an isogram. There we go. But many characters. One more. And you know what? You have all been survivors because you've survived 1511. Apparently this is an isogram. That's an awkward little situation. Okay, so, oh my goodness. I just wanted to say a huge thank you to you all. That was really fun. I hope it was kind of fun for you. We can do numbers. I've still got it running. It's going to say it's an isogram even though it shouldn't. That's there you go, something for you guys to fix. But I hope you have a good week ahead. I hope you have a good study break. Please don't panic. Okay, we did harder questions in the lecture than there are going to be in the exam. I hope that you feel that way. And thank you very much. Don't panic in the exam. Do your best. Remember, it's just a mark in a first year course. It doesn't really define you. It doesn't matter, it doesn't matter, right? What matters is, and something that you can never be taught, is to be nice to others and to be a good person. So just be kind to everyone and support each other. You've got this and you're going to do great in the exam. I really had so much fun teaching you this term. I really wish I wasn't away for those first 2 weeks. Those are always my favorite. So, and thank you to Bella and Sophie for doing amazing moderation, and to Liam for doing the camera and stuff, and for doing some very aggressive throwing in the lecture. So thank you all so much for engaging and for showing up. It's been so lovely. And if you ever need anything, just shoot me an email. I'm always here and I love to have a chat. So good luck for the exam. Good luck for the rest of the week, and I will see you at the exam, okay? And we will have drop-in sessions as well before the exam, so come along and get help as well. We will announce it on the forum. Bye, everyone. I hope you have the most amazing week. Oh, I'm gonna cry.